everyone, in this question we have a cylinder which has mass m is equal to 10 kg and radius r is equal to 0.1 meter, and a force F is acting at the top, that is point Q, and it is with the help of a fishing line that is wrapped around the cylinder. And in the first part of the question we have to find the acceleration of the center of mass of the cylinder. So for that the magnitude of F first of all is going to be 12 Newton. So here if you look at the diagram, let this be the center of mass and this be point P. If the cylinder will move forth, the point P will have the displacement in the opposite direction, so the frictional force will act in the forward direction, let this be small f. So we will apply Newton's second law. So according to that, summation F is equal to ma, and then F plus frictional force will be equal to ma, center of mass. We know that the moment about point P is equal to the moment of inertia about point P into the angular acceleration of point P, so that will be equal to F into 2r, the distance or the perpendicular distance, and this is will be equal to moment of inertia mr square by 2, thus mr square into alpha p. So from here we can see 2fr will be equal to 3 by 2 mr square into, we know the alpha will be ACM by r, as you know alpha is equal to a upon r. So here a will be the a center of mass. So from this we can see a value of 2f comes out to be 3 by 2 m a center of mass. So from here we can see we will put the value, we can see ACM comes out to be about 1.6 meter per second square, and let this equation be equation number 1. Now for the second part of the equation we have to find the angular acceleration. We have to find the angular acceleration of the cylinder about the center of mass. So for this we know that a center of mass is equal to angular acceleration of P into the distance between the point, that is r. So this will be equal to 1.6 into alpha p into 0.1. Alpha p comes out to be this comes out to be 16 radian per second square, and now we know the acceleration, the linear acceleration of point Q will be equal to, this will be equal to angular acceleration P into the distance between both the points, that is 2r. So here AQ will be equal to 16 into 2 into 0.1. So this comes out to be 3.2 meter per second square, and from this we can find, we know that this AQ will be equal to alpha center of mass into the radius. This is also equal to this, so 3.2 upon 0.1 will be equal to alpha center of mass. So this comes out to be 32 radian per second square. In the last part of the question we have to find the frictional force Fk. So for that we know the friction force here, that is equal to F. This is equal to F. So we will again apply, we will add upon the we will equate all the forces. So 10 ACM minus 12 F will be equal to 4 Newton, and if you want to represent it in vector notation, it will be 4I cap plus 0 J cap. So this was the final answer. Thank you.